If we consider this diagram here, we can see it's split into two and a half of it is shaded. This one is split into four, two parts are shaded, but we can see, looking at the overall picture, that this is a half of it, 2 out of 4, or 2/4. In the same way, 3/6 must be the same as a half as well, and so must 4/8. So we have a half is the same as 2/4, is the same as 3/6, is the same as 4/8. Can we spot a pattern? Well, one pattern that I do spot is that every time the numerator of the fraction goes up by 1, the numerator being the top number, the denominator goes up by 2. So we could continue this by putting a 5 here and a 10 on the bottom. This one's gone up by 1. This one has gone up by 2. There's another pattern we could spot as well. We could go directly from this fraction to this fraction without doing all the ones in between. Because if we have a half, if we were to multiply the numerator by 5 and also multiply the denominator by 5, 5 times 1 is 5 and 5 times 2 is 10, taking us directly to here. So let's look at this one. A quarter is the same as 2/8, 3/12, and 4/16. So every time the numerator's gone up by 1, the denominator has gone up by 4. So this would be 5/20, 6/24, and 7/28. Note that just like here, we could have achieved this without doing all the in-between ones. So if we had a quarter and we wanted to express that over 28, then this is multiplying by 7. If we multiply the numerator by 7 as well, we end up with 7/28. Now for this one, we can see the numerators are going up by 1, the denominators are going up by 6. So 5/30, 6/36, and 7/42. Once again, we could get from here 1/6 to any of the others without doing all the steps. So for example here, if we wanted to express it out of 24, then we have multiplied the denominator by 4. If we do the same to the numerator, then we do get 4/24. These are all called equivalent fractions because they're all the same as a quarter, just represented differently.